Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our third lesson on logic. In the last lesson, we learned about compound statements, truth tables, and the properties of conjunction and disjunction. Today, we will learn De Morgan's laws and define the terms contradiction and tautology. We will also learn to determine the equivalence and the converse of given compound statements. Are you ready, students? We will begin by defining De Morgan's laws. They state that for any propositions P and Q, the negation of P or the negation of Q is equivalent to the negation of P and Q. We can prove this statement using a truth table. The other law is the negation of P and the negation of Q is equivalent to the negation of P or Q. This can also be proven using a truth table. These are simple laws, but they will prove very useful to us as we learn more about mathematical reasoning. Now that we have learned about De Morgan's laws, let us try an activity. Working with a partner, complete a truth table for this compound proposition.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Have you finished your truth tables? We can fill in the first two columns in the regular fashion. The third column, not Q, must obviously have the opposite truth values of the second column. The statement P or Q only has a truth value of F if both propositions have a truth value of F. The statement P or not Q has a truth value of F when not Q has a truth value of F. What about the last column? We find that the compound statement always has truth value T and F depending on the truth values of P and Q. A compound proposition is a tautology if and only if, for every assignment of truth values to the component propositions occurring in it, the compound proposition always has truth value T. A compound proposition is a contradiction if and only if, for every assignment of truth values to the component propositions occurring in it, the compound proposition always has truth value F. For example, observe this statement. P and Q and R by implies P and Q and R. We know that conjunctions are associative and commutative. So these two statements are equivalent. Therefore, if we construct a truth table for this compound proposition, we find that it will have a truth value of T regardless of the truth values of the component propositions. Do you understand? Good. It is time for another activity, everyone. Construct a truth table for both of these statements. Try to determine if each statement is a tautology, a contradiction, or neither. You can get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I hope that you have finished each of your truth tables. What did you discover about each compound proposition? If you constructed your truth tables correctly, you found that the last column contains only T as a truth value. Therefore, you concluded that the first statement is a tautology. You also discovered that the truth table for the second proposition contains the truth value not all T, not all F in the last column. Therefore, the second statement is neither tautology nor contradiction. Were those your answers? Excellent. Now let us study the concepts of the converse and the contrapositive. Mathematical statements are usually given in the form of a conditional proposition, such as if P, then Q. Given a conditional statement like this, the statement if Q, then P is called its converse. As well, the statement if not Q, then not P is called its contrapositive. P is said to be the hypothesis or sufficient condition for Q. Q is said to be the conclusion or necessary condition for P. As an example of this, consider the following propositions. An animal is a salmon. An animal is a fish. We can write the statement, the converse, and the contrapositive in full sentences and determine the truth value of each. If an animal is a salmon, then it is a fish. This is true, so the truth value of this statement is T. If an animal is a fish, then it is a salmon. This is obviously false, so the truth value of the converse is F. If an animal is not a fish, then it is not a salmon. This is true, so the truth value of the contrapositive is T. In this way, we can prove the validity of a given statement. Many times, mathematical theorems are given in the form of conditional statements. In order to prove a theorem, we can assume that the hypothesis is true, and thereby show that the conclusion is true. If this approach is too difficult, however, we may use a technique called proof by contrapositive. We have time for one more activity. Give the converse and the contrapositive of this statement. Do your best, and I will be right back.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello once more. Here is our statement. The converse statement is, if 3 is an even number, then 5 is greater than 10. The contrapositive statement is, if 3 is not an even number, then 5 is less than or equal to 10. I hope that you found the same answers. Great work. Today, we have learned about De Morgan's laws, tautology, contradiction, and contrapositives. Until next lesson, thank you, teacher. Thank you, students.